Hello. All right, last week you calculated a disparity index using police stop data and racial distribution of a subset of the population in Nashville. And I asked you to think about other data sets that you could use to make a similar comparison or answer a similar type of question. Some of the great ideas you came up with included comparing behavior of male and female coyotes on their landscape, calculating the disparity of clean water availability across a distribution of income levels, looking at racial distribution of national park visitation. There were some really good ideas. And I just wanted to talk through a couple of simple and relatively silly examples of what these kind of selection indices or differential kind of indices look like. So we're going to go to a dog park. And our dog park is covered half in grass and half in pea gravel. If we throw our population of dogs in there, and if they exhibit no preference for where they stand or play, we would expect them to become uniformly distributed across the landscape. And because the area is half grass and half pea gravel, we would expect half the population to be found on grass and half to be found on the pea gravel. But we're going to go out and make observations about the actual use of the park area. And it's this difference between what we would have predicted if the dogs are uniformly distributed around the park and what we actually observe them using that creates the basis for the comparative index. There are a lot of ways to quantify this relationship, but in our case, we're going to simply subtract the predicted values that come from a uniform distribution from our observed usage. So what we see when we go out and observe our population is that 7 of the dogs are on grass and only 1 dog is found on the pea gravel. It's a simple calculation to divide 7 observed on grass into the whole population of 8, which results in 88% of the population utilizing the grass, and then the inverse, 12% using pea gravel. Okay, and then like I said, if we subtract our expected, the 50% of the population that we would expect to be using grass, if we subtract that from what we observed, 88%, we end up with values above and below 0. Positive values show a preference and negative values show avoidance. But it's important to know that these values aren't normalized, so we can't really determine the strength of preference or avoidance. This is just a very generic positive, negative quantification. Another type of comparison that we can make, instead of how dogs in general are using land cover, is we can look at the difference in behaviors within our population. So based on breed in this case. Within our new population of 10 dogs, our distribution is 30% labs, 30% bulldogs, and 40% chihuahuas. If we assume that any dog breed is just as likely to get its head stuck in a fence as any other breed, we would expect that out of 100 reports of a dog getting its head stuck in a fence, that 30 would be labs, 30 would be bulldogs, and 40 would be chihuahuas. That's assuming equal behavior from all dogs and equal opportunity to get their head stuck in a fence. But if we actually observe 100 incidents of dogs getting their heads stuck in a fence, and in 99 of those cases it's a bulldog, well, we can compare what we expected to what we observed to assess the differential behavior between breeds. And this table just shows that same very simple math. I did set this up as 100 observations so that we can think of it like a percentage or, simplifying down to a proportion. But it's the same kind of math where if we expected them to be distributed the same way their breed is distributed within our population, we can compare that against what we actually observed and get a disparity calculation that's, again, just positive and negative numbers, not normalized, so not looking at strength as we move away from 0. And we're going to get into that when we look at some radio collar data and calculate home ranges. But this is just a quick kind of primer in a couple of different ways that we could think of a differential index and how we could use population data to calculate some of these differences or quantify some of these differences.